Good morning, everyone. I'd like to begin by acknowledging the traditional owners of the land on which we are gathered today, the Gadigal people of the Eora Nation, and pay my respects to their elders past, present and future. So look at the gathering today. This is actually a record. I think I gave arguably the first talk ever in this series about a decade ago, and there was me and about 4 or 5 people in a room somewhere in the MLC Centre. Today we cut off people coming at 425. So this is a record, so Cathy, you can come back again. And also it's my very, very great pleasure today to introduce Dr. Cathy Foley, a very, very distinguished scientist, 30 years with CSIRO, and I understand what will be nearly 20 different roles of various descriptions. She's contributed so many things to society, to the translation of science, to women in STEM, to being involved with things, to getting us all to do stuff, that it's just an enormously long list to mention. So it's fantastic that she's here today to really talk about what future science will look like. Future science is going to be hugely important to this state as we transition away from resources, as we need to worry about drought, as we take on new types of technologies, as we do a whole range of different things. And CSIRO are in the forefront of this, and Cathy, in her role as CSIRO's chief scientist, is in the lead position of really thinking about where it is we need to invest and what we need to do in the future. Cathy, as I said, is a very, very distinguished scientist. I've known her for well over a decade. She has a long, long list of awards. The Clunas-Ross Award is one that comes to mind, but she also has received awards from the Australian Institute of Physics, from materials science, from lots of different areas. So she's really incredibly well respected and really sees across so much of science, I think, in this state. So it's great that she's here with us today with our record attendance. Cathy, with no further ado, thank you very much.
So, well, first of all, thank you all for getting up early this morning, and thanks, Hugh, for turning on a beautiful day, so it wasn't too horrible getting out the door early. I also want to thank you for setting up this series, because I think it is important. But like you, I want to start by acknowledging the traditional owners of the land we're on today, the Gadigal people of the Eora Nation. And the reason why I want to do that is when we talk about future science, I want to turn around and look the other way and say that we actually have people or on a land which we've had the longest civilization going for 65,000 years. And in one part, up in Brewarrina, we don't often realise that we actually have, well, let's go back. If I said what's the oldest engineered structure in the world, people would probably think the pyramids. In actual fact, we have them in here in New South Wales, and it's the fish traps, which were created 40,000 years ago and lasted up until 1960 when a weir was built, which then messed them up. But they provided for the Indigenous people here ongoing fish and livelihood and food for the decades or the millenniums. And the thing that's interesting was that it kept on going regardless of drought and flood. So using that inspiration, I sort of thought, well, let's look at Australia at the moment and Sydney, or New South Wales in particular. And I sort of tried to do a timeline. So this is one is now and going backwards in time by tens of thousands of years. And I sort of you can see there we've got Indigenous people and then the fish traps being set up. And then we go forwards to colonisation in 1788, and then we've had lots of wars and things, and here we are today. So if we go and look at the fact that those fish traps lasted an awfully long time, and I think all of us would love to have an engineered device that lasted that long. Most of our fridges would be lucky to last 10 years. But if we look at from 1915 to 2015, we actually did see huge progress. And we had, for example, for those who are getting older, only 1 in 20 of us in 1915 would have been over 65 years old. And now it's 1 in 5, thank goodness. In 1915, we had lots of men compared to women, but now it's the other way around. Yay. Sorry, guys. And then infant mortality was about 10%, and now it's 0.3%. So these are all really positive things, and they're all a consequence of understanding particularly medical research and also hygiene and a whole lot of things that are a consequence of science. But today we are facing, particularly in New South Wales, we've got drought. We've got the Murray-Darling Basin, and we just heard in the news yesterday, it looks like we're going to have more fish kills next summer. And we've got the Great Barrier Reef looking like it's really struggling. If you look at the Australian National University's annual environmental indicators, they haven't put the one out for 2018 yet, but this is a 2016 one, and you can see it's not too bad. And just look at the river flows, 11% there. Let's look at the one a year later. The river flows is just an example, minus 20%. So I'll go back, plus 11, minus 20%. We're in a situation where our environment is really changing rapidly. I realise it'll flip back and forwards, but we're seeing this huge variation in things that are really affecting us. We saw this year in May. It was a big month for things environmental. So there was indication from a major report from the United Nations that we're going to be losing 1 million species in the next little while, which is going to have an enormous impact on our biodiversity. And then all of us have also probably seen last May when there was lots of reports, including for Australia, where we've been shipping off our rubbish overseas, and guess what? They're sending it back again. And so what are we going to do with our recycled materials? And we live in a country where we have lots of coal. And so as you can see, it's a major contributor to our energy supply. And then if you look at our industry mix, it's a whole range of different things. But the thing we're hearing about is that industry, jobs, things of the future are going to be different. So what is our future industry going to look like? And look at our health. So we are now in a situation where we're third in OECD for life expectancy, and that we're going to live well over 80 years old. But unfortunately, due to obesity, mental health, and heart disease and so on, 11 of those years are going to be with illness. And the thing that's also worrying is that half of our population is actually dealing with chronic illness. So that means half of you in the room today have got some chronic illness, which isn't a good place for us as humans. The world has been looking at all these problems, and that's just a snapshot of them, and come up with the United Nations Sustainable Development Goals. And the thing that's really interesting is you can see from clean water and sanitation through to life on the land. There's a whole range of different ones. But in our world, we've recognised that things have been changing really fast. So we've got these goals, but we're also recognising that the reason there is need for sustainability is the world is changing fast. So since 1900, we've seen a lot of change, and we think it's accelerating now. So let's have a look at an example. This is Fifth Avenue in New York City in 1900. Lots of horses and carts, and I've circled the one car. Let's look a few years later, 1913, same street. Can you see the horse and cart? Whoops, circle's just in the wrong place, but just a little bit to the side there. So you can see a massive change. And part of the reason for that was the introduction of the factory line, where Henry Ford was able to put in the idea of making cars available, have a business model so that everyone could afford a car. And what's going to happen in the future with into the future from now on, are we going to be seeing driverless cars, which will really change the way we are operating, from the way transport happens, the way we own cars, through to the point where 700 laws have to change if we're going to have driverless cars in Australia. So there's a mixture of the science, the business, and the government regulation that is all needed to make things happen and change quickly. Another ubiquitous technology, though, that really has made an impact on us is something that actually hasn't needed quite the same regulation. So in 2005, if you went to see the Pope, this is what you would have seen, people actually looking at the Pope and maybe saying a prayer or two. A few years later, we now get to a point where we all experience life through our mobile phone. So we've got those changes in technology that absolutely change the way we operate. But the thing is that information and knowledge is changing rapidly too. And I've got some numbers here to just give you an indication. So if you look at measuring the growth of science by either publications, it's growing exponentially, or actually this is ditto to, or information for scientists is we publish far too many papers because the number of ideas is actually growing linearly, but still growing at a great rate. That means the amount of knowledge we have, and this is a way of looking at it, is doubling every year. And you can see from 2000, the amount of information that's available is growing at that great rate. And you can see different points along the way of major technologies. So why is that? Well, the first thing is we're spending more money on research and development. Well, maybe not in Australia, but in other countries. So that's just an indication of spending GDP in Australia. I've just put a blue line there, arrow, and then a percentage of GDP is there. So you can see that, especially in places like USA and China, growth of expenditure in research is going up. That means we're going to have huge volumes of information coming through. And those huge volumes of information is incomprehensible, not in just the size, but the fact is we cannot comprehend all that information. So just giving an idea of what does that mean, how much information is that? I thought I'd give you an example of a comparison. So if we said a megabyte, which is about the size of a large novel, is the size of an ant, the length of an ant, then if we had a gigabyte, so that's like the information that's in the human genome, is about the length, equivalent of the length of a short human. And then if we said we had a terabyte, which is about the annual world production of literature, that's about the length of the Sydney Harbour Bridge. And if we had a petabyte, then that would be, and that's about all the US academic research libraries, that would be about the length of the Great Barrier Reef, which is about the same size as New Zealand. So if we look at an exabyte, which is only 2/3 of the annual production of information we have today, that would be the equivalent of the diameter of the sun. So you can get an idea of the huge volume of information that is growing. So with all this information, why is it we can't solve all those problems that I mentioned earlier? And one of the problems we have is that they actually fight against each other. And this is an interesting paper which was written by Brian Keating, who's now retired from CSIRO back in 2017. And in that, they went through saying that actually to solve these problems, they fight against each other. And in fact, we're going to have to make some hard choices if we're going to work out which of the problems we're going to solve. Because when we solve one, it actually impacts another. So with all those sustainable development challenges, one of the things we've done is actually looked at what is appropriate for the Australian context. And so we've went through in our organisation at CSIRO and said what is it that are Australia's greatest challenges. So the first thing is, of course, we need sustainable energy and resources. We need a secure Australia and region, and that includes not just physical security but also biosecurity. We need future industries, and I'll explain why that's a different colour in a minute. We need resilient and valuable environments. And we also need food security and quality, and we also want to have health and well-being. So they're sort of, I know, seemingly like motherhood statements, but if we actually were able to nail those, we would actually have, utopia here. But the thing that's interesting is that if we're going to solve any of those problems, every one of them needs a new future industry. Problem is, though, if we're going to solve these problems, something has to change. And so what I want to look at is my 5-step plan for sort of how things have to change in the way we do and look at science and how we implement it. So the first thing is, if we've got all this information that is incomprehensible, can we actually use the opportunity of using digital things like huge computers, artificial intelligence, machine learning to be able to deal with domain science so we can take that information and turn it into knowledge and decision making so that we get to a point where we see data as the new oil. So in doing that, it means we have to be able to integrate all the massive data sets and have new breakthroughs from that. We're going to be creating new data from all the automation and sensors that feed real-time information so that we can have decisions. For example, imagine if we had the Murray-Darling Basin all wired up so that then we could create a digital twin, getting all the information in and turn that information into something which gives us the ability to have real-time testing of what if we, for example, opened the dams and flushed the river through like a toilet so that we'd be able to freshen it up and we do that at an appropriate time, but then also check, will that have an impact on the amount of water we've got, so that if there's an ongoing drought, we won't run out of water. These are the sorts of things which we could potentially do. Data access and the actual data has to be critical and contestable. And we also need to make sure that, and we're seeing this already with a lot of social media platforms, is that we don't want to get to a point where we have a concentration of the data in private monopolies, so that therefore it's not accessible and able to be dealt with. And we need to have digital ecosystems that are cooperative, with cooperatives emerging. So that's sort of the data situation, but there's also general purpose technologies that are under development. And this is some work which was done by the World Global Forum, and they do a report every year, and this is in 2018. And just to give you an idea of how accurate they are, they use a range of instruments to go through and check what is the future going to look like. And just an example of where they got it right was in 2014. They actually predicted that fake news would be a major impact in 2016 in the US election. So I think they got that one right. So and they're looking at negative consequences versus benefits. But if you look at the things that are ranking, particularly in the benefits, artificial intelligence, robotics, biotechnologies, which is like synthetic biology, new computing technologies like quantum computing, advanced materials and nanomaterials, and energy capture and storage and transmission. So just quickly look at these. What are we having happen here in science in Australia right now? Well, self-healing materials. Wouldn't it be great? You have a car accident, you scratch something, it self-heals. The idea of having nanomaterials which are allowing you to have the intersection of organic, inorganic and biological materials that create materials with disparate properties. That we have things like graphene which will allow us to do things from water filtration to new low energy electronics, through to new materials which can be fully recycled by having a closed loop, so that we end up not throwing a lot of waste, say, into the oceans. That we are getting to a point where we have 4D printing, not just 3D printing, so we're able to have a whole lot of information as we build things up through 3D metal printing or plastic printing. We're actually able to do certification, so that we can be able to say that a part can be created, say, to replace a part in an aeroplane, and it's certified as you make it. And then finally, energy materials, which allow us to be able to use a whole new range of ways of having sustainable energy sources. Another example is synthetic biology, which we've seen the capacity of transistors on a chip growing, so with Moore's law, but the same thing's happening with the ability to read our DNA and also be able to write DNA. And we're getting to a point where, when we first did the human genome, we are actually seeing it as being a sort of $100 million project. And now it's getting to a point where you can measure or test or read your own genome for about $1,000 per person. So, and the ability to write DNA and be able to change it is getting cheaper as well. So this means there's a whole potential new industry which is using a design, build, deploy, where we're going to see the intersection of biotechnology, information technology, manufacturing and automation suddenly create whole new industries for us. And using that methodology, we're going to be able to have plug and play ways of being able to use biomaterials to be able to create new materials, such as, say, in Queensland, where they've got all the wheat or the cane fields, instead of them creating sugar and sending it overseas or else giving it to us and making us fat, is that we'll be able to turn that into feedstocks that will create a whole new materials industry. Having a high throughput design and construction, which allows us to do this quickly, and then also having open frameworks for data and sharing things. And then we think this will be really disruptive, and but to do that will require artificial intelligence to be able to help us get that information and make those decisions. So we're going to get to a point where we're going to have hybrids that allow us to have ultimate connectivity, and that we're going to have the ability for us to have augmentation that allows us to really be our super selves, I guess. So, but to do that means it's going to be transdisciplinary, and there's a whole lot of social science there that we need to make sure that we have the social license to do that. So what does the future hold for science and research? So we go through and look at this. We can see that all these tools are going to impact us who are scientists, and I want to just have a look at those. I actually think we're going to see the future labs changing and the fieldwork we do and the infrastructure be quite different. So, for example, at the moment we do animal testing, when we're trying to see how things interact with biological systems. We're going to get to a point where we're going to have things called organoids, where we can test things on organs on a chip. So at the moment, animal testing is quite difficult to reproduce, and we'd be able to get fast track of being able to make sure that what we're doing is actually real. We're going to have this genome foundries, which I talked about before with synthetic biology, allowing us to make artificial tissues. In the chemistry lab, instead of having wet labs where you go in and do an experiment, we'll be going and doing a lot of the experiments in a computer first before we actually go and into the lab and do the chemical experiment, because we'll have great understanding of how things interact. And the way we visualize data will be in such a different way that we'll be able to have a brain-computer interface which will allow us to actually absorb this. You can sort of see this already when you go into some of the 3D caves, which go through and really help us to see huge data sets be able to present to us in ways which we can comprehend better. When I mentioned before going out into the Murray-Darling Basin and putting a whole lot of sensors out there, that will replace us going out into the field and doing a whole lot of measurements, coming back, and then 6 months later having analysed the data saying there's going to be fish kills in 6 months ago. And so we're going to be able to have that real-time, hi-fi, in-field, ubiquitous sensors that will give us real-time information. But to do that, it actually requires huge computer power. And that in itself, remember I said these things fight against each other. The computer powers we need will actually contribute to energy usage and therefore increasing greenhouse gas emissions and all the things that go with that. So we're constantly struggling. How do we actually make sure that we get that balance right? We're also going to see new ecosystems develop in science and technology. So we're going to be seeing the idea of open science, where we're going to be sharing data and have cooperation. We're going to make sure that we have open innovation so that we have co-creation and challenge models that actually put up there where a whole lot of people will be able to work on a single problem, so that therefore we get multiple minds working hard on that. When you do that, though, you've got to make sure you get rewards and recognition. At the moment, we have pretty much a dog-eat-dog type approach to making sure that people are capturing their own research in a way that gets the recognition, that gets them the promotions, the awards, and other grants. So one of the things that would be interesting is, can we create a sort of a blockchain tokenization that we're able to go through and track where everybody's contributions have been, so that, for example, when it comes time to, say, having an outcome where a fabulous research outcome has ended up into a major manufactured or an industrial product, we'll be able to work out exactly the attributions all the way through and be able to make sure that everyone gets their return on investment. We're also going to see a huge change in the way publications and peer review will happen. We're already seeing the tip towards open access, so that all of us will be able to access scientific publications. Already we're seeing some of that already with open data being available, and there's a thing, for example, archive, where papers are published before they're, placed on the internet before they're published. We're going to start seeing crowdsourcing of reviewing of papers to really shift the way we think about peer review. But the most important thing is repeatability and statistical significance is going to be having a higher and higher expectation, because at the end of the day, as researchers, if we do not have the integrity and trust of our community, then we are not going to be able to do anything at all. So I want to just mention for a minute, what does this artificial intelligence and machine learning actually mean? So one of the things we've been looking at is, how can we create sort of a future science platform that uses that? So the first thing is, we've got to have the data platforms. They've got to be robust ecosystems which can draw this machine learning and artificial intelligence. From that, we've got to be able to extract features. From those features, we can then model what things look like, so that we can predict what they are, what's going to happen, so that then we're able to have that data-driven learning, which will allow us to make decisions. But to do that, we need to make sure we've got the ethics, responsible research, the robustness and causality, and the explainability of it all. So it's not just something we just all put in there and let the computers do it all. We actually have to make sure that as a society that we go along with that, with the social license. So future science is going to be more data-driven. We're going to be more augmented. We're going to be able to deal with complex tasks. We're going to have an explosion of different tools which will allow us to have, for example, I can't wait for this day because my typing is so terrible that all the things will be put into a computer by either my thinking and in it goes, or my speech. And then the other one is that also we're going to have publications that are going to, or the way we report on our science, that is going to be able to be mined by artificial intelligence and machine learning, so that then we'll be able to get more information from the individual papers brought together. So that's the first thing, changing the way science is done. But the other is also, I think we've got on the cusp of something really changing, and New South Wales is really at the centrepiece of that in Australia, and that is the second quantum revolution. So what are we looking at there? And no, it's not a Vegemite sandwich. Do you know what that is? It's the first transistor. So it was a little device about a bit under a centimetre in size, and from that we've got to a point where it has changed our lives completely. And the thing that's really interesting is that the number of transistors made today as per month is equal or more than the number of ants on the Earth. So that's how ubiquitous the number of individual transistors are. And as a consequence of this, over sort of 60 or so year period, we've actually changed our world in a way we can't comprehend. But the thing is, we've got a second quantum revolution coming, which is actually looking at some of the other quantum properties, which I'm not going to go into today, but will allow us to have secure communications, metrology, quantum computers, sensors, simulations, and biology, so that we can, instead of just having a classical approach to the way we look at living things, that we understand them in a much more non-classical way, so that we can do much greater prediction. So, for example, instead of when we're doing simulations of the way we look at things, if we have time scale and system size, instead of things just being huge, large scale, we'll be able to get right down to correlated quantum chemistry, understanding the way the biology works, that allow us to have true digital twins. I mentioned that before with the idea of a digital twin for the Murray-Darling Basin. But we already have digital twins on any physical structure, so that whether it's a building or whether it's transport like in an aircraft, we're going to get to a point, though, where our bodies and our health will be in a sort of digital twin, because we truly will understand that. So number 3 is, where does Australia fit in solving all these interconnected problems, which also fight against each other? We've got to remember that Australia's a big land mass, but we're only 0.3% of the world's population. There's our square of population compared to the rest of the world. Yet we actually do 2 to 3% of the world's research. So that's massive. But that means, though, it's only 2 to 3% of the world's research, which means we have to be connected globally if we're going to be able to solve all these problems. And we do really well. Australia has fantastic research. We're ranked first in our technology readiness level, third highest in the number of universities in the top 100, which is unbelievably fantastic. Fifth in global entrepreneurship. Says CSIRO, this was not done by us, but it's top 1% of scientific institutions. We're almost 49% of Australian firms are innovative active, and 43% of Australians have tertiary qualifications. So that's really fantastic. What a great position to work from. However, remember how we've got to be everyone's friend and work internationally. Our collaboration and translation sucks. And you can see that when we're bottom of the OECD. So that means that something really has to change. And so what I want to look at is our sector. How is it the science sector in Australia is not working in the way it could to take all that fabulous science and turn it into something that can solve all these great problems? So if you look at this sort of tablecloth there, it's been put together where at the top you've got the university funding, and this is sort of showing levels of funding. And I've squared there, they're the publicly funded agencies like CSIRO, ANSTO, Defence Science and Technology and so on. We've got the industry research funding through the tax R&D incentives. We've got then that pink area, which is the research and development corporation funds like the grain and wool. And then we've got directed research, which is things like ARENA, which funds research into new energy, and other CRCs, for example, which is a cooperative research programs which allow the idea of taking research from universities into industry. So one of the things I wanted to do is, actually I'm going to go back to this, is that quite often when we talk about the research sector, what I've noticed is that it's like we put it all into a blender, pull it out and come up with a jelly, and we sort of think that every part of the research sector is the same. But I want to put a different model and say, could we actually achieve bigger and better impact if we actually had clarity on our roles and responsibilities in the sector? So if we wanted to have new ecosystems of industries and utilities, what if we were to have from pure research, basic, applied, tech development, and then production, so that we've got at one end, the green end, we're looking at where people use the stuff to make the difference, through to where at the end we've got pure research from universities, and we see the ability to pull things through by making sure that everyone sees their place. I think we're going to see much better outcomes. So we're going to see better ecosystem operating, which will allow us to see that movement through and be able to have that impact, so that instead of having an institution trying to do it all, we actually have a sort of ecosystem model, so that we have a Valley of Death services program, which things like incubation, prototyping, development, commercialisation and funding, so that we're able to take those great ideas and take them to application. That we actually use those platforms which I talked about before of being able to open innovation, connecting all those ideas so that we get to a point of solution. That we have talent platforms, because one of the things that's really important is that we have more movement across all the sector. At the moment, we have the university sector, government labs and industry, and what we don't see is a huge amount of movement between that. So imagine if we were able to have the students, government labs, industry actually working and moving across each other so that they could share information, experiences, and have really rich and fulfilling careers. Can we make sure that our research platforms are the ones which I described earlier on? And can we make sure that we have those data platforms that are interconnected so we can share that information? But to do that, we also need to make sure we have that computer infrastructure, which is not cheap, and we have to remember that it also has an impact on energy. But if we do that, we'll connect the system, we'll be able to do things at scale, we'll be able to lift productivity, and we'll be able to we'll make sure that we've got the computer access so that we can do all that. But if we do that, I believe that we'll have innovation accelerated. But one of the things interesting is if we look at the way we do research, quite often it's done in small teams. And I've only just put that up just to say that this was something which a research project looked at this. And what they did was look at the size of teams. And what they found was that if we do want to have disruption, and we need disruption if we're going to solve the big problems, that is done by small teams. The difference is, though, if we want to have impact, we have to have bigger teams. So how can we make that happen from small teams to larger ones to make sure that we are able to address these challenges or missions that are ahead of us? So as a nation or as a state, we need to build the world's best teams. We also need to attract the talent. We need to have best minds doing this. We need to be able to have the scale and focus to be able to make that into something that has that ability to translate. We need to inspire the nation, because this is the way that we can encourage our youth to realise that there are great opportunities by studying science, engineering, mathematics, and be able to go through and see how there is careers for them to actually make that difference. We need to provide confidence to students so that they know where they can choose careers, where there are jobs of the future. We need to make sure that we're supporting the startups and the multinational companies to invest here so that we can see that work research translated. We also need to focus on what is really needed, and then also make sure that we link the sector for integrated impact. And I think if we do all those things, we're going to start seeing the ability to address all these challenges. So I'm going to just show examples with CSIRO, which is where I've worked. So we are, if you remember, where Australia is 3% of the world's research. CSIRO is only 3% of Australia's research. So if we're going to have the impact as an organisation that we seek, we actually can only do that by collaboration. And so you can see here that is something which has been absolutely critical for us in order for us to have the scale. But to deliver on any mission, remember I've said this before, we actually need to have, in actual fact, a whole supply of small businesses, because when we look at a big solution, for example, if we were going to put a whole lot of sensors around the Great Barrier Reef, remember I said it's the same size as New Zealand, if we're going to have a whole lot of sensors up there being able to measure, for example, the nitrates in the water, which you can't do at the moment, by the way, then we will need someone to make those devices. We need someone to do the logistics and put them in place, maintain them, take the data, turn that data into information and make decisions, or help give government information to make decisions. So that means that any solution actually has a supply chain of small businesses, which is great because Australia is a land of small to medium enterprises. 97% of our businesses are small to medium enterprises. And so one of the things we're also doing here, and there's lots of places happening, not just in CSIRO up here at Linfield where I'm based, where we've got a collaboration hub, but at other universities around the place, and also the state government is setting up these hubs so that we've got a place to incubate these small companies. And this is just one example here where we've up at Linfield based on the Boosting Business Innovation, which has been an absolutely fantastic program, and I hope you keep it going, and I'll just use the example there with one company, Baraha, which is looking at that LiDAR system for driverless cars. Started, I think in September, it'll be 4 years since they started. And last week or the week before last, we were reported in a financial review of being worth $145 million. And one of their guys was listed on the top young rich list. Now, 4 years ago, they were actually using their credit cards and friends and family to fund their research. And they've gone from being two guys in a garage coming into CSIRO, being able to scale up, and now they're employing way over 100 people and exporting and manufacturing things. So that can be done when you get the system working together. And this is something where I think New South Wales is particularly well poised to do that. But it's the ability to scale. So not just doing lab things, but being able to take things to that scalability and pilot plant is really important. And also being able to inspire our researchers to understand that a potential job for them in the future is not just going on and being a university academic or working for CSIRO, but to take their great ideas and turning them into businesses. So the ON program, which was developed, it's an accelerator program which researchers come and learn, and also small to medium enterprises come in and work out how to create a value proposition from their research. And from that, operating in just 3 years, 35 companies have already started up from that. And so we're already beginning to see a shift. Great opportunity too with is the potential for us to use digital industries to really boost our economy. Some research was done by Alpha Beta Digital Innovation Report last year, which showed that Australia is potentially missing out on $315 billion worth of opportunity. If you look at the total economic value with existing industries and digital industries, I'll just circle the one at the bottom, you can see that the growth of digital exports is very low for Australia. We're only capturing 20% of that. So if we're able to pull this all together, there's huge opportunities for our economic growth. But remember, success needs, as we went right at the beginning with the cars and mobile phones, you need a technology that is needed. You need to have a business model that works, and think of the Henry Ford and his cars, or mobile phones, or Amazon, or iTunes. All those sorts of things had disruptive business models. We need to have easy and seamless to adopt. And we also remember that government has a place to have the regulation to make sure all the things come together. So remember Australia's greatest challenges, which I identified. Well, for us to do that, let's look at an example. So, for example, if we want to have sustainable energy and resources, we want to have a future industry, and we want to have resilient environments, what is one project we could do to look at solving all those problems? And one of the things we've looked at is hydrogen as a replacement for high impact energy so that we can have transport for long distances. So the idea is that we take water, we use solar energy, we split it, and then from that you're able to create hydrogen, and also we're able to get nitrogen from the air. You can put that together to create ammonia, which is then able to be shipped, and so therefore we have a new export industry. The only problem is that there was a little big problem was that how do you actually get the ammonia to then split back into hydrogen really easily? The other thing that's necessary too was all the different things, and we've been slowly up at Newcastle and in other places and universities around New South Wales, been pulling together all the different components that allow us to have a hydrogen energy system. But there was that missing thing of how to create that hydrogen into ammonia. And in 2007, we actually funded this project. Remember, we said disruptive ideas come from a small team. And a young researcher said, I think I've got an idea for a membrane which could actually turn ammonia into hydrogen in a very efficient way. And so this is something that was developed and now has been the ability to close that loop and fill that hole so that we're now able to really look seriously at having a hydrogen energy future and export. So that this is our vision, is there's the now, where at the moment we've got oil, coal and gas as a major part of our energy mix. By 2040, we're going to see hydrogen really growing, and that whether it's nuclear or not, this is more for other countries, but the possibilities there of having other energy mixes are something for us that it could become a reality. But with that comes a business model. And one of the things which we've been doing is looking at developing industry roadmaps. And you can see there that the National Hydrogen Roadmap is something which is actually showing us the pathway forward. And so as a consequence of all this work, we've had Twiggy Forrest, who some of you know as a miner, is actually investing in hydrogen and saying, is this the new energy or new industry for us in Australia? Problem is, a bright idea takes about 20 years for it to become a product. So is there some way we can do differently? And it's also, wouldn't it be great if we just had a bright idea, do something, and in comes an industry? What you're looking at there is something that Bob Frater put together. He was the person who shepherded Wi-Fi, which was just developed up the road here at Marsfield. And as you know, Wi-Fi has actually changed the world as we know it. It was done with CSIRO in collaboration with Macquarie University. And you can sort of see the cosmic genealogy there, he described it. And what you can see in the white boxes is where the training and the development of the staff happened. And then there were a whole range of different things where they had developed a whole range of different technologies. But eventually, David Skellen from Macquarie University worked out a way of getting the Wi-Fi developed by CSIRO and Macquarie University into IEEE standard, and the rest is history, because as we know, Wi-Fi changes us as in every possible way. But the thing that's really interesting is that you can see that it definitely wasn't an idea, do some work and turn it into an outcome. So we need to accelerate the cycle of innovation. So if we think that we have a new innovation, we go up and we're very excited about it, and we have the peak of inflated expectations, and then usually you might see something where reality hits and we go to the trough of disillusionment, and eventually you have to hang in there. That's a valley of death, I guess, and eventually you get a technology which becomes ubiquitous. How can we make that smaller, shorter? And I think the things I described so far will help with that. Whoops. So what will the future science look like? Well, if we go back to 1990s, looking backwards, we're all thinking about new math, as something, and our textbooks look something like that. As many of you might remember, that's what we had at school. Well, also back then we had the World Wide Web was just beginning to emerge. We had Hubble Space Telescope just going up. We had the Human Genome Project just starting. We had Bose-Einstein condensates, which probably none of you have ever heard of before, but they're actually the basis of being able to have clocks that allow us to have GPS working. We were able to start animal cloning and gene silencing, so to be able to manipulate DNA. When you type in to Mr. Google or Dr. Google, what does 2040 look like? This is his picture. He also had something that was completely inappropriate there with the robots and people. So I covered that over with what Sydney Harbour Bridge is going to look like. I think we're actually going to see something quite different. We're going to actually see, for example, the way we think about things really changing. And in fact, we're going to start having a point where our children will start to think with quantum thinking naturally. They'll start to think with artificial intelligence and machine learning as just being natural, just like their kids today know how to program remote controls or go and get into a phone and be able to understand how all the different menus work. And that's going to get to a point where we have this already with Chris Ferry from CSIRO. Saying that you can go and buy quantum physics for babies. And we've got a range of different future science platforms, which I'll just go through, with autonomous design of robots. So from having skins, that means that robots can go into fires and not melt, and be able to have a way of evolving their structures, so that we're going to have a whole new way of developing robots. That we're going to have water technologies of the future, say, based on being able to do filtrations through things which are based on, say, graphene type filters. We're going to be seeing industry which, instead of at the top where you see the traditional thing, to being much more modular, precision, sort of laser-like targeted ways of being able to do things in small quantities for just in time. We're going to have sensors, materials and robotics that allow us to be able to really understand our environment and make real-time decisions. So just to finish off, I want to finish with a personal reflection. As I've actually worked for CSIRO for 34 and a half years, and I have had 19 roles. It'll be 20 because I'm going to be filling in for Larry Marshall as the Chief Executive while he's on holiday. So I'm really excited by that because that means I've had just about every role in CSIRO you can have. And this is my claim to fame, which, just in case, that's a grain boundary, that line there, that's a transition electron micrograph. That grain boundary, that little line down the side there, is about a nanometer. Your fingernails will grow a nanometer in the next minute, so just to give you an idea of how small it is. And we use that to make a magnetic sensor. It's a quantum sensor for a mineral exploration tool called LANTEM, which has discovered billions of dollars of mines around Australia and internationally. So that was something which is my career in a nutshell. But the thing that was interesting was when I first started, I actually come from a Catholic background. I actually had this idea that I wanted to save the world. I think it was, youth camps and stuff like that. So in 1975, when I finished my HSC, I actually went and worked in Bourke on a mission an Aboriginal mission up there. And really, at that stage, saw an Indigenous people who really had lost their way and had lost their culture. And also, we hadn't really realised what they had to offer. But the thing that's interesting, remember I said earlier on that we're going to be really struggling with many of the issues. And we've got 1 million species potentially being extinct in the next little while. The research that was done looking at biodiversity and ecosystems actually went through, and the thing was interesting, and I've just made that big, they went through 15,000 articles and found that if we're going to solve these problems at scale, and especially in countries like Australia, we need to draw on Indigenous knowledge. And this is something which I think is only becoming aware for us, that we've actually not recognised the depth of knowledge, even though it's transferred in ways which is really different to a Western approach. There is a huge opportunity for us to partner with our Indigenous people to actually learn what those issues are. So that one of the things we're doing is our future science is also going to be including Indigenous knowledge and know-how to be able to help us really push the boundaries on this. So last slide is that our future science. Well, I've given you a 5-step plan of how I think we need to work through it, but it means that we have to make sure we're answering the right questions. We have to make sure that every one of us knows our role in the sectors so we can support the solution. We need to work collaboratively. We also make sure that we use the opportunities of new materials, synthetic biology, quantum, artificial intelligence, machine learning and data, that they're going to require interdisciplinary and multidisciplinary solutions. That's not an easy, straightforward way. It's going to be messy, so please bear with us. That every solution is going to require new industries, businesses to realise that translation. We need to work with integrity and make sure that we hold a social licence to do any of our work, because otherwise it will be rejected, and rightly so. And we need to embrace Indigenous knowledge and know-how, but also what's most important is that we have to work together with government, academia, publicly funded research agencies, industry, both locally and globally. So with that, I want to thank you.
So we thank you so much, Cathy. It was a fantastic tour through what the future might be. We've got time for a couple of questions. Do we have microphones anywhere? No?
Just yell really loud. I'll repeat.
Cathy, Martin Thomas, that was an extraordinarily inspiring talk.
Oh, thank you.
Crucially, it has got to get to many of the people who are not here, the young, in my case, grandchildren, in the case of many around here, their children. What is the best mechanism for transferring what you, the inspiration you've just given us, into the young of Australia?
Okay, how am I going to inspire Australia?
Well, we did video this and it will be on our website. So.
Actually, what you're saying is really important, is that outreach. So this is National Science Week, and I think every person who is a researcher really has an obligation to go out and contact their school, to actually go through and realise what the opportunity is there. And by talking to young people, so for example, last night, my little Joey Scout group of 6 and 7-year-olds, we did Science Week with doing lots of things. And kids love science. They can't get enough of it. And I think we need to make sure we keep inspiring them when they get into high school as well, when they suddenly think other things are not so cool. So that's a challenge. I'll take that on board.
Good. Other questions? Yes.
One of the things that bothers me about decision making, coordinating with government and business to get this proposal through that you're suggesting here, how can we do that at a high level?
Yeah, so that's... So there's a couple of things.
That's where we work together.
Yes. I actually think it is all about people actually working together and not trying to hold things to themselves, not thinking that they are the solution themselves, but also recognising that we have a whole lot of artificial barriers. So states, for example, should I say that? But it's is that we should be looking at, not just states, not just nations, but globals. That's the first thing. I think the second is that we need to make sure that we elect people to make decisions, and so we need to make sure we have information that is available in a way that is palatable, that a way that is actually understanding that it's not black and white. If it was black and white, everything would be really easy, but these are really complex issues, and you solve one problem. So say in a government department, they solve one problem. And I thought there's a really classic example of some years ago, I think they sent out tape measures for all of us to measure our waste and to try and stop eating so much. That was one government department in health. And then another one is trying to build industry, the food industry, say buy more food and do stuff. So, they're working against each other. And so this is something where it's all about this, trying to get this balance to work. And also recognising that we have to understand that maybe as a nation we have to make decisions on what we will and won't do. And that's where, who we elect and us as the voters have to make those decisions.
Change is uncomfortable too.
It certainly is. We all hate it.
Can we just do, yeah? Sorry.
Thanks, Cathy. Great talk. Branwen Morgan from UTS. We're developing Outbreak, a data-driven decision-making system to tackle antimicrobial resistance,
Yes,
global problem.
Very exciting.
Multidisciplinary, requires lots of input. But one of the things I'm particularly interested in is not just the research translation and that curve or the length of that curve to translate research, but it's the end-user piece, it's the adoption piece, and that's a huge problem. I mean, getting clinicians to change really simple things in hospital systems, for example. What are your top tips for getting the adoption segment of research translation accelerated?
That's a really important question, and thanks for that. The reason is it's important is we're at the moment developing a decadal science plan with what we're calling cross-cutting capabilities. And everyone's fainting because I've got things like marketing and economic stuff, social science and usability. And that's where I think that, I said multidisciplinary and interdisciplinary. Multidisciplinary is saying the different disciplines coming together. Interdisciplinary, I think, is where we're actually having one impacting the other, like quantum biology or something like that. But it's the multidisciplinary stuff is really critical. And at the moment, we do tend to be siloed and say, okay, we've got the social science here, and then they try to influence things where it's not integrated. And I think my view is that's the only way we're going to see things progress. We all know, for example, you've seen an app or a computer program, you think the usability is just not there. And that's where we need to understand how humans interact with things. So as we said, change is hard and uncomfortable, but you have to make it as comfortable as possible. And, with any of these things, if the value proposition is there, we can see, people buy cars and change the way we do transport in a short space of time. Same with mobile phone use. So you've got to make it so it's ubiquitous, easy to use, and something which is an obvious thing to do, and the barrier to adoption is as low as possible.
Last question.
Thanks, Cathy. That was a great talk. I'm Nisanka. I'm from the industry. I work in Commonwealth Bank. I just want to ask you, in our industry, the artificial intelligence is really getting hotter, and where our banking will get changed. Are we really investing in AI? Whenever I read any research, we are really behind on AI. Mm-hmm. And like China, are we going to, like technology, are we going to import AI tech skills also? What's going to happen to Australia?
That's a really, so remember I said we're 3% of the world's research, so we're going to be 97% friendly with everybody. So look, this is where, remember I said you've got to choose the right things to work on. This is something which, as a nation, we tend to have everyone working on whatever they think is a good idea. Maybe, I'm not sure what you think about this, is that we're going to have to start identifying things where we actually say we're going to focus on this. And that's where, if you have that sort of challenge model saying, well, this is a major challenge which we're going to work on, and let's focus on that, because Australia does have specific requirements and needs which are different to the rest of the world. So focus on the things which are specific that no one else can solve, and then I guess reality is we're going to have to just buy in stuff, and that's life. It's a global world, even though maybe some countries don't think that.
Thank you so much, Cathy. Everyone, thank you.
Oh,
Thank you very much.
Oh, thank you. Oh,
Thank you very much.
thank you very much. Oh,
All right.
lovely.
So just very briefly, yes, it's Science Week this week, so it's wonderful actually that we had Cathy here. And a reminder also for our next talk in a kind of series. I hope you've noticed the theme this year around the prosperity agenda, so science that basically is translatable. We've got Liesl Yearsley, who's CEO of a new AI company in Sydney. So she's going to be talking a lot about how computing, AI and data and humanity engage with each other. So very topical, very relevant to the kinds of things that we saw today. So thank you everyone for coming on what is a world record breaking morning. Thank you so much.